Any other problem? Okay. So what is the problem? So I'll just give it. Okay. So here actually the problem statement is given x plus y plus z is equal to a. Lagrange's method of multipliers. So given x plus y plus z is equal to a, find the maximum value of x power n. Find the maximum value of y power n z power p. So for this function actually we have to find out the maximum value for x power m, y power n, z power p subjected to the condition of x plus y plus z is equal to a. Now, so we will form the function, that is, so the function for which we need to be finding out the maximum value will be x power m, y power n and z power p. And the so condition is phi of x comma y comma z is equal to 0, and this condition from this is x plus y plus z minus a is equal to 0. So this is the condition actually we have to be using it. Subjected to this condition, we will be finding the maximum value for this one. So dou u by dou x. So dou u by dou x is nothing but, so with respect to x we are doing m into x power m minus 1 into y power n into z power p. So this is dou u by dou x. So then dou u by dou y, it will be n into x power m into y power n minus 1 into z power p. Similarly, dou u by dou z is equal to p into x power m into y power n into z power p minus 1. So this is the first derivative of the function for which we have to be finding out the maximum value. And then the condition is, so dou u, so this is dou phi by dou x is nothing but this is 1, dou phi by dou x. Similarly, dou phi by dou y is equal to 1, dou phi by dou z is equal to 1. Now, as per Lagrange's method of multipliers, dou u by dou x plus lambda times of dou phi by dou x, this is equal to 0. And similarly, dou u by dou y plus lambda times of dou phi by dou y is equal to 1. Dou u by dou z plus lambda times of dou phi by dou z is equal to 1. Right? This is 0. So these are the three different conditions. So along with the original condition x plus y plus z is equal to a, so we will have to solve for this one. Now actually if you put it exactly in the same format, this is x power m into y power n into z power p times m by x plus lambda times of 1 is equal to 0. And similarly, the second condition is, so second condition, x power m, y power n, z power p, and this is n by y plus lambda times of 1 is equal to 0. And then the third one is p by z times of x power m, y power n, z power p is equal plus lambda times 1 is equal to 0. Got it? So till this point understood, Midun? Understood? Okay. So once you understand this one, then we will be solving all these equations. These equations are now these equations whatever we have got, right? So if you notice lambda by, so the original function u is equal to x power m into y power n into z power p. So this is u. So if I say this is m by x times of u is equal to minus lambda, or m by x is equal to minus lambda by u. Similarly, n by y times of u is equal to minus lambda from equation number 2. It implies n by y is equal to minus lambda by u. Similarly, p by z times of u is equal to minus lambda. It implies p by z is equal to minus lambda by u. Or you can write everything in one single equation, that is m by x is equal to n by y is equal to p by z is equal to k. So where k is equal to minus lambda by u. So it is anyway constant, right? So you can just treat it as it is like this. Now from this, actually what you can find out is, so there is one relation I told you, that is, so m plus n plus p. So this value is equal to m plus n plus p divided by x plus y plus z. So this same k value is equivalent to this one also. I told you this yesterday, right? So how it is going to be equal? Suppose if I take this as k, then m is equal to kx and n is equal to ky and p is equal to kz. Then if I substitute here m plus n plus p, then it will be k times of x plus y plus z. So x plus y plus z and x plus y z will cancel out, k will be left over. That means this equation is exactly equal to the k value. I hope you understood this. Got it or not? So then this is nothing but, so this value is nothing but m plus n plus p divided by x plus y plus z is equal to a, which is a given condition. So since x plus y plus z is equal to a, this is a condition. Now from this, actually you can find out the values of x, y, z. So if you know the k value, m by x is equal to m plus n plus p divided by a. It implies x is equal to am by m plus n plus p. Similarly, y is equal to an by m plus n plus p. Similarly, z is equal to ap by m plus n plus p. So this is how actually you got the values of x, y, z values. So if you want to find out the maximum value, u max will be, so x value you can substitute, that is am by m plus n plus p whole power m into an by m plus n plus p whole power n, ap by m plus n plus p whole power n. Got it? So if you separate the numerator and denominator separately, then a power m, a power n and a power p. So all these things will come out. So that is a power m into m plus n plus p. So this will come out. A power m, a power n and a power p. It will come out. Now m power n, m power m, n power n, p power p. This will be left over. And in the denominator, so m plus n plus p is common, whole power m and whole power n and whole power p. So this is m plus n plus p whole power m plus n plus p. So this will be the answer. Got it, Midhun? Okay. So note down one famous problem. If at all, if there is a possibility of asking the two different constraints problem, this is the only problem actually usually it will be given in all the examinations. Find the stationary values of x square plus y square plus z square subjected to the conditions ax square plus by square plus cz square is equal to 1 and lx plus my plus nz equal to 0, and interpret the result geometrically. So can you try to solve this problem? This is one of the famous problem. Almost in every textbook it will be there. You try to solve this on your own first. Anybody got the idea how to do this? Sometimes actually the same question is even asked to find out the maximum and minimum values of the function given by x square plus y square plus z square, subjected to the conditions of ax square plus by square plus cz square is equal to 1 and lx plus my plus nz is equal to 0. So this is the conditions actually where there are two different conditions are there. So the procedure is straightforward and simple, but the simplification is a little complicated. So the function f is nothing but the original function for which actually we have to be. So this is phi. I call this as this function as u, and this function as phi, and this function as psi. So then this is u plus lambda times of phi plus beta times of or mu times of psi. So this is how actually we have to frame the function first. Then so dou f by dou x is nothing but dou u by dou x plus lambda times of dou phi by dou x plus mu times of dou psi by dou x is equal to 0. This is condition number 1. Similarly, with respect to y, with respect to z, so you have to solve all the three equations together along with this condition and this condition. Then actually you will get the relation between x, y, z values with respect to lambda or mu, right? So as above told, so lambda value is coming out to be minus u. So I think he gave the answer. So you try to solve on your own first. I'm going to solve it for you anyway. So but I give you 2-3 minutes time. You try on your own. Anybody got it? Other than Anubhav? Now this implies for us, see this, dou u by dou x, lambda times of dou phi by dou x and dou psi by dou times of mu. Now here u is nothing but x square plus y square plus z square, and phi is nothing but ax square plus by square plus cz square minus 1. So that is how actually you will write it. So phi of x comma y comma z is nothing but ax square plus by square plus cz square minus 1. This is equal to 0. So this is the format actually you have to express it. Similarly, here also psi of x comma y comma z is equal to lx plus my plus nz equal to 0. This is how you can express it. Now here dou u by dou x is nothing but 2x plus lambda times of dou phi by dou x is nothing but 2ax plus, so this is L is equal to 0. So this is one condition, right? Similarly, you have to apply all the conditions, then solve for that equation. Got it? This is mu L here. What is the question, Nitya? So other equations you are writing. Okay. So this is, so with respect to y actually if you want to do it, so this is dou f by dou y is equal to dou u by dou y plus lambda times of dou phi by dou y plus mu times of dou psi by dou y. This is equal to 0. This is equation number 2. From this, so this is dou u by dou y. Dou u by dou y is this one 2y plus dou u by dou z, sorry, lambda times of dou phi by dou y. Dou phi by dou y is 2by plus mu times of, so this is with respect to y, so this is m. So this is the other equation, and the next equation is dou f by dou z is equal to dou u by dou z plus lambda times of dou phi by dou z plus mu times of dou psi by dou z is equal to 0. It implies the equation number 3 will become 3z plus lambda times of 2cz plus mu times of n equal to 0. So these are the three different conditions. Got it? So these three conditions actually we can use along with the original conditions of phi and psi together, so that you will be able to get the values of lambda or mu or x or y or z. So any of those values you can solve. Three different equations here, two original equations together, it will form the 5 different equations, and then 5 different variables x, y, z, lambda and mu. So but out of all the 5 variables, you are interested to find out only x, y, z values, not the mu lambda values. In between, if there is an opportunity that you can avoid these mu comma lambda values, you can still do that, right? So that's why actually we call this as undetermined coefficients, right? So for that actually what we can do is, first actually I will simplify this into x plus a lambda x plus mu by 2 times of L equal to 0. And similarly, you can avoid this also. I hope you noted down this. I will be erasing. Then this is x plus lambda ax plus mu L, mu by 2 times of L equal to 0. And then I will multiply this entire equation with x so that I can get the value in this particular format, x square plus y square plus z square, and ax square plus by square plus cz square format, and lx plus my plus nz format. If I multiply this entire equation by x, then I am going to get it in this format. That is x square plus lambda ax square plus mu by 2 times of lx equal to 0. So this is equation number 4. Similarly, divide this entire equation by 2 and multiply with y, then you are going to get the same format, y square plus lambda times of by square plus mu by 2 times of my equal to 0. This is equation number 5. Similarly, the last equation, divide by with 2 and then multiply with z this entire equation. This is going to be z square plus lambda times of cz square plus mu by 2 times of nz is equal to 0. This is equation number 6. Now if I add all these three together, that is 4 plus 5 plus 6. If I add all the equations together, this will be x square plus y square plus z square plus lambda times of ax square plus by square plus cz square plus mu by 2 times of lx plus my plus nz equal to 0. Now, from the given conditions, lx plus my plus nz is equal to 0, and then ax square plus by square plus cz. So this value is coming out to be 1. So this is x square plus y square plus z square is u. So this will be u plus lambda times of 1 plus mu by 2 times of 0 is equal to 0. Or, so u plus lambda is equal to 0. It implies u is equal to minus lambda. Got it? Understood? So this is the condition. So you got the value of u in terms of lambda. Now this value we can substitute back. Okay, so note down till this point. So this is u only, not mu. This is u. Got it? Note it down. So u value is coming out to be minus lambda. So then actually the original equation x plus lambda times of ax plus mu by 2 times of L is equal to 0. This is the original equation. Then if I want to express lambda in terms of u, then this will be x minus aux plus mu by 2 times of L is equal to 0. Or this is au minus 1 times of x is equal to mu L by 2. Or x is equal to mu L by 2 times of au minus 1. Got it? Understood? Similarly, the value of y actually you can bring it from the second equation. So in the second equation, that is y plus lambda by plus mu by 2 times of m is equal to 0. If I substitute the value of lambda to be minus u, y minus u by plus mu by 2 times of m equal to 0. It implies y value you can put it as y is equal to, so this is mu m by 2 times of bu minus 1. Similarly, z is equal to, you are going to get, that is mu n by 2 times of cu minus 1. So these are the values of x comma y comma z, which are nothing but the stationary values in terms of u. Got it? Understood? Now these values, if you want to put it in the original equation, that is lx plus my plus nz is equal to 0. So if you put it in this equation, Here L times of x is nothing but mu L by 2. So that is mu times of L square by 2 times of AU minus 1 plus M mu times of M square by 2 times of BU minus 1 plus mu N square by 2 times of Cu minus 1 is equal to 0. So this is the final equation what we have got. Here actually, if you notice, this problem is a little different from all other problems. So when there are two different conditions that are involved, most probably the complexity of the problem is very, very high. So this is one such kind of case. Now here, finally what we have got is, so this is in terms of, so sorry, this is all u. This is mu1, yeah, correct one. So this is, so in this equation, right, if you notice, this is a quadratic equation in terms of AU, because if you bring this 1 to the other side, then it will form a quadratic equation in terms of U. So a quadratic equation in terms of U will give the solutions, two solutions for U. So because this is a quadratic equation in U, right? So if you take one part to the other side, then cross multiplication will lead to a quadratic equation in U. So these U values, you are going to get one as the maximum value and then minimum value. So two solutions we are going to get if you solve this quadratic equation. Got it? Understood? Okay, fine. So the geometrical interpretation of this is, we have three different, I hope you noted down this. Yeah. So the geometrical interpretation of this particular problem statement is, that is, three different equations actually we have got. So one equation is the function for which we need to be finding out the maximum value, x square plus y square plus z square. So this is the function u. And the second condition is ax square plus by square plus cz square is equal to 1. And the third condition is lx plus my plus nz equal to 1, equal to 0. So these are the three different equations. So what these three different equations represents for us? Now see this. This is nothing but lx plus my plus nz is a plane passing through origin. So it's a plane passing through origin. And this is an ellipsoid with center at origin. Center at origin. Now this is x square plus y square plus z square. So this is nothing but the distance from the origin, right? So this is a spherical shape. Now actually what it represents for us is, this is okay. So ax square plus by square plus cz square is nothing but an ellipse. Got it? So this is an ellipse, and then there is a plane passing through this. Right? So there is a plane passing through this. Now this one, this plane actually, it will cut this entire ellipsoid. Now this will form an elliptical shape like this. So this will be an elliptical plane. The intersection point, if you notice, correct or not? Got it? So this is a plane passing through origin. This is a plane and this is the ellipsoid. Now the distance from the origin is the function actually for which we want to find out the maximum value or minimum value. Now the intersection points of this entire curve. So this is a conic section. It is an ellipse. Ellipsoid became ellipse after cutting with a plane. Now if you find out the distance from the origin to any point on this particular ellipse, that is the plane ellipse, is nothing but two different locations where you can get the maximum value or the minimum value. So one location is, that is, so this ellipse actually is nothing but, this is the minor axis and this is the major axis. This is the major axis. Now from the origin, the distance is minimum at the minor axis end and maximum at the major axis end. So these are the 2 points. This is 1A and this is B. So this is nothing but U max and this is nothing but U min. Got it? So the end of the minor axis is the minimum value. The end of the major axis is the maximum value. So, but how we got this particular frame is we have cut this ellipsoid with a plane given by Lx plus My plus Nz is equal to 0, subjected to those conditions. That means it has to be present on both this ellipsoid and this particular plane together. And then the function value x square plus y square plus z square is nothing but the 0. So distance from the origin, and that distance will be maximum on the major axis n and minimum on the minor axis n. Got it? Because once we cut this, this will again form a ellipse. Clear? Understood or not? So how do we say this is an ellipse? So given equation is ellipsoid, and then the ellipsoid actually, if we cut in any particular random shape, it will always lead to an ellipse. Got it or not? So ellipsoid is, in whatever the way actually you look at, there will be an ellipse shape. Any questions? So this will be the last class for the differential calculus, right? So I'll just summarize whatever we have discussed. So that is, we started with, so I'll just go through the syllabus. So we have started with real numbers, and then so what we have discussed is the functions of real variables, and then we extended the same discussion to the limits and continuity, and the limits and continuity is extended for the mean value theorems, and from the mean value theorems we derived the Taylor's expansion, and from there we derived the Maclaurin's expansion, and then from there actually we moved on to the other aspects, that is multivariable calculus. Okay, so we moved on to the multivariable calculus, wherein so the function is continuous or differentiable. We tested with 2 different variables, and then we moved to the Jacobian. Jacobian is the point, like suppose if u is a function of x comma y, and then v is a function of x comma y. Now if you have a curve which is there in x and y coordinates, then this curve actually, if you translate to uv, then this will be a different kind of shape actually you are going to get it. So this different kind of shape now actually translated in terms of u and v. Now if you wanted to find out the integration, so dx dy is translated into du dy. Now in this translation you have to multiply with something called Jacobian. This Jacobian actually we have derived it with the help of these relations. That is, if you want to find out this one, dou u by dou x and dou u by dou y, dou u by dou x and dou u by dou y, dou v by dou x and dou v by dou y. So the determinant of this actually, we said that this is nothing but the Jacobian, which we are going to use it in case if we want to translate from one coordinate system to the another coordinate system. Same is the case even with the Cartesian coordinate system to the polar coordinate system, or Cartesian to the, so 3-dimensional Cartesian coordinate system to the cylindrical coordinate system, where we multiply dx dy dz is equal to r times of dr d theta dz. So that r is coming extra, which we call as the Jacobian, which will be calculated in this particular format. Similarly, we discussed the Cartesian, so we discussed the translation from one coordinate system to the another coordinate system, that is cylindrical and spherical coordinate system. In the spherical coordinate system, we multiplied with one more factor called r square sine theta, because that will be the Jacobian format. So Jacobian is nothing but the translatory multiplicating factor. So this translatory multiplicating factor. So if it comes here, it will be 1 by times of j. That means du by du dv, if you want to convert into dx dy, then you have to divide with 1 by z. Yeah. Got it? So this is how actually the Jacobian is getting used. Then so we discussed the partial differentiation. So partial differentiation actually it has a lot of applications, and all the engineering problems are going to be solved only with the help of partial differential equations. So very little applications of the ordinary differential equations, but mostly the practical problems, especially the latest trends of research, are dependent on partial differential equations, right? So partial differentiation is the basis to understand the partial differential equations. So that we have covered it in detail, and different relations that we framed with the help of the homogeneous equations, and then try to relate the homogeneous equation differentiation with a standard formula, right? So these are the things actually what we have discussed as part of the partial differentiation. And the applications of the partial differentiation, especially we have discussed only for the maximum and minimum value calculation. This maximum and minimum value calculation, right? So two different methodologies we have adopted. So one is the plain methodology, for which actually we have derived all the required conditions. How we got it? So from the Taylor's expansion, we have derived the required conditions to find out a maximum value or minimum value. And those conditions, once it is getting satisfied, then actually we found the method to find out the maximum value or the minimum value based on the conditions that it satisfies. And then from there, we moved on to this one. This is the Lagrange's method of multipliers. In this case, so the method of finding out the maximum value or the minimum value is very easier, but the limitation is so it will not say whether you have got the maximum value or the minimum value. So you need to interpret physically. So that's why actually here actually it didn't say whether we have got the maximum value or the minimum value. From this actually we interpreted this as the minimum value and this as the maximum value. So this with the help of Lagrange's method of multipliers. In that actually with one condition and with two conditions, two different cases we have discussed. So most probably the questions that are going to be asked are only with the one condition, but with the two conditions, this is the only famous problem which every textbook contains. Got it? So all are actually subsets of this only. So if you know this particular method, then you will be able to adapt to any kind of problem that will be given based on the two different conditions. Got it? And then so we have even discussed the curve tracing part also. So wherein we try tracing the curves. So for different kinds of curves actually. So how we are tracing there actually we'll be finding out the important axis, the asymptotes, and the important points that needs to be noted. So those things actually we have to calculate it and then try to identify in the graph, right? So that is about the curve tracing. Got it? So these are the things actually. So to summarize, we have discussed in detail in all the aspects. So if you have any questions on any of these aspects, you can let me know now. So from tomorrow onwards, we will be shifting to integral calculus. Any questions? So I hope every aspect is clear. Got it? Okay. So if you have any questions on any of the aspects in the differential calculus, whatever we have discussed till now, so and the material whatever I have given to every student, that will be sufficient enough to handle all these kind of questions, and I have covered rigorous number of models there, right? So you can go through all those things. If you have any questions, you can let me know. Got it? Okay, so if there are no other questions, so I'm going to log out. So this is only a summarization of all the aspects. So tomorrow onwards, the class will be as usual, and then I'll be just introductory. So tomorrow will be the introductory class, and then on the integration part, and then we'll continue with the integrals and the applications of multiple integrals. And the next class, whatever we are going to deal with, that is the integral calculus. It forms the basis to understand the vector calculus. That is very important, because there actually we will be handling the double integrals and triple integrals. The triple integrals, when we are solving it, so we have to appropriately identify the shape of the graphs. So that will form a little bit of toughness, right? So if you are able to identify the volume that you wanted to integrate, then the integration part will be easier, but identification of the volume is a little bit tougher. But those are very much necessary to identify the volume shapes and the surfaces that are bounding the volumes. So in understanding the vector calculus, wherein we have the theorems like Gauss divergence theorem and the Stokes theorem and the Green's theorem, right? So those theorems actually which we have to understand in detail. Why? Because this understanding is even needed to understand the fluid dynamics part, right? So fluid dynamics anyway is part of mostly the vector analysis and the complex analysis together will form the fluid dynamics. So these things actually are interdependent on one on the other. So tomorrow onwards, whatever we are going to start, you try to understand carefully. If you have any questions on any of the aspects which you are not very clear, you can ask me then and there itself. Then only we can move further, because other topics actually you can understand if you understand only the multiple integrals. Clear? Got it? So yeah. So you can go through BS Gravel only. BS Gravel is one of the very good book for calculus part. So it covers the practical aspects of calculus. That is, I like that book very much. So I follow that book only. BS Gravel, Higher Engineering Mathematics. Got it? Go through the multiple integrals. He clearly explained each and every aspect there. Got it? Okay. Yeah. So that's all for today. Yeah. Thank you. Good night.